Welcome to Elemental Chem Talks. Today, I'm going to discuss significant figures from class 11, right? So now, when we do any experiment or when we measure any, values, each and every value it has some amount of uncertainty, right? It has some amount of uncertainty. So now this uncertainty it depends upon measurement, how accurate it is, and it also depends upon skill of a person. For example, I would like to measure the weight of a wooden box, okay, or any iron box. Now I'm using one platform balance. I'm using platform balance. By using platform balance, let's say it is having weight 9.4 kg. And same block, if you use analytical balance, so our answer will be around 9.4 to 3 kg, something like this. Assume this. That means here the value getting differed. So the last value, that is 4, here this is uncertain, right? So the uncertainty in any experiment or measured values, it will be indicated by significant figures, right? Significant figures. So we can define significant figures like this. These are the meaningful digits that are known with the certainty plus the last one known with uncertain. The last one known with the uncertain. Those are called as significant figures. Now let's see how to calculate significant figures in a given value. So here we have certain rules. In that, first one is all non-zero digits, all non-zero digits are significant. For example, I am taking 489.5. So in this value, number of significant figures are 4, right? Same way, 2.136.5. Here also number of significant figures are 5. So all the digits will be considered as significant figures here. This is rule number 1. Next, rule number 2, zeros in between non-zeros are called significant. For example, 1.008. So here there are two zeros, they exist between 1 and 8. So they are also considered as significant figures. So here total significant figures are 4. Same way, 109.5. So here also 4. So if 0 exists between two non-zero digits, that is also considered as significant. Next, when it comes to rule 3, zeros preceding to first non-zero digits, like this now, 0.0051. So here number of significant figures are 2. Same way here, 0.1, number of significant figures are 1, right? Next, come to rule 4. Zeros at the end and right of a number are significant if they are right of the decimal point, like this, 119.00. Then here number of significant figures are 4, right? 1.05. Number of significant figures are 3. See, of course this is not relevant here. See, 0.10. So here number of significant figures are 2. So the first preceding 0 is not significant, and next these two are significant, 1 and 0, right? And all counting numbers have infinite significant figures. All counting numbers, nothing but 2 balls or 2 bats, 250 students. So this kind of counting numbers, they have significant figures, infinite. We have infinite. Why? Because they are exact numbers. Why? Because they are exact numbers. And we have another rule, that is rule 6. Now I have taken one number, let's say 100. So it is not having any decimal point, and these zeros are right side of the 1. So these zeros you can consider as significant, or maybe may not, may or may not, right? Because here, for example, if you write like this 100, then significant figures are 2. If you write like this 1 into 10 square, then significant figures are 1.00 into 10 square, then significant figures are 3. So it depends upon the way how we express the number, right? I hope you all understood. Thank you.